So hello everyone, my name is Sagar and my topic is about flip-flop. So before going to that, let us see what are sequential circuits, okay? So it is a type of digital circuit where the output depends not only on the current input but also on the past or previous input, okay? So we know the basic NAND gate or AND gate, okay? It consists of this an AND gate. Let us see NAND gate only. If you give 0, 0, see, if you give 0, 0, the output will be 1, okay? And here only your output is depending only on two inputs, okay, only on two inputs. But let us see here, it's depending on previous input also, okay, depending on previous input also. So that is the sequential circuits. So here memory elements will come, okay, memory elements come, which stores the data, one bit of data. So in types of memory elements, there are two types of memory elements. One is a latch. A latch is a memory element that stores one bit of information and works continuously based on its input. So example, SR latch, D latch. So flip flop. This is my topic. So let us learn briefly this. Flip flop is a memory element that also stores one bit but updates its state only at specific time when it is triggered. Means when it is clock is triggered. So types of flip flop means SR flip flop, D flip flop, and JK flip flop. Let us learn first what is SR latch using NAND gate. Okay, we can construct this using NOR gate also, but we will prefer. I'll prefer NAND gate. So this is basically a basic representation of a NAND gate. Okay? So this is NAND gate. Sorry, using NAND gate SR latch. Okay. So let us give directly the inputs. Okay. If you give 0 1, see, I'll give 0 1. So here, since the NAND, what are the properties? We know that the properties of NAND gate. If one of the input is 0, the output will be 1. Okay. So this is the output. This will go to here. So 1 1. So what is 1 1 of NAND? It's 0. Okay. So what we get? So this is actually the output here. See, I have written here. Sorry, here. This is the output of this. Okay. Similarly, you can do 1 0, which will come on. It will come 0. So let us learn first. Let us give 0 0. Okay. If you give 0 0, see, 0 means one of the input means 0 means we have here 1. The output will come here 1. So what is 0 and 1? It's 1. See, this is actually q bar. Sorry. If this is q is 1, but q bar should be 0, but here is 1. So that's why this is invalid state. Okay. Invalid state. Here I have written. So if you give 1 1 means let us see 1 1 by q1. So here is 1 1. If you give 1 1, see here we can't predict because none of the input is 0. So here let assume here q. Okay. Input given is q. So if we take NAND of these two means 1 dot q and bar. So this is nothing but 1 bar plus q bar. Means your output is 1 bar means 0 plus q bar means q bar only. So your output is coming is q bar and this is q bar. Okay. So here also if you do, you can see q only. Okay. It will come q only. See, q bar means this is in whole state. Okay. In DDCO, it will they will tell me whole state. Okay. So this is basic representation of latch. You can derive SR flip flop using NAND gate with the help of latch. Okay, let us see that also. So this is actually SR latch. Sorry, SR flip flop. Let it be. Okay, we will main focus on this. See here only you can see this is nothing but SR latch. Okay. So directly we will give input See here, I have written here not trig means your clock is there, no, that is not triggered till now. Okay, means this will current input will be same. When it is triggered, let us assume by giving 0 1. Okay, let us give 0 1. If you give 0 1 means, see, the property of NAND gate says that if one of the input is 0, the output will be 1. Let me clear this. Okay, 0 1. If one of the input is if one of the input is 0, the output will be 1. Okay, and here clock is triggered means it is 1. Okay, input is 1. If 1 1 means 0. See, in latch you can see what is in latch, this is SR latch. So input is coming 1 and 0. What will be the output? 0. See, 0 1 0 1 1. Sorry, 0. Here also 0. Okay, so this is basically SR this is basically SR. Sorry, this is basically SR flip flop. Okay, so let us see what are JK flip flops. Okay, so see here, you can see here, see, when we give 1 1, it's telling invalid. Okay, so let us see. Okay, sorry, let us give 1 1. Okay, yes is 1, this is 1. Since clock is triggered, here also one input will be gone, here also one input will be 1. Okay, so this output will be 0. Okay, 0. See, if the both inputs are 0, what are the outputs in latch? Is our latch.
So, hello everyone, my name is Sagar and let us see the question. Design verilog program for implementing the various types of flip-flops such as SR, JK and D. In previous video, I have said what are these flip-flops. So let us see first of all D flip-flop. The code you are seeing is nothing but a D flip-flop with a synchronous reset. The module has a data input D, this D, data input and output Q and a complementary output QB. Okay, so this is QB and here is an and and a clock input CLK and a reset input RST. Okay, so let us see in what are and all inputs are there. Okay, so here D CLK are there, no? So that's what the data D is the data input and the CLK means the clock input which triggers the flip flop. So whether you should trigger it so that it can run, and RST means the reset input. Okay, which resets the input to 0. And let us see the output. The main output of the flip-flop which stores the value D at the rising edge of the clock unless reset is asserted. Okay. So here QB means the complementary output which is simplified to negation of Q. So let us see the always block. The always block at block assures that the logic is evaluated on every positive edge of the clock. Okay. So and here the begin is the built-in keyword. So inside the block there is a conditional check for RST. Okay, conditional check is there. It's nothing but if RST is high. Okay, if RST is high, the output Q is immediately set to 0 on the next clock cycle. If RST is not asserted, that is the value of Q is updated mm, on the value of D. So this is done using a case statement. Okay, this is the case statement. So this is the case statement. Let us see the case statement. When D is 0, Q is set to 0. When D is 1, Q is set to 1. So I have made a video, no? So there you can see that the output is same as the input. Okay. If you give input 0, the output is 0. If you give input 1, the output is 1. So that's what. The complementary output of QB will be the assigned as a negation of Q. Okay. Negation of Q will be assigned. So this is what D flip flop program, verilog program. So let us see SR flip flop verilog program. Okay. So let us see direct inputs. Input are yes set inputs. Okay. And R means reset input. And CLK means clock. We should trigger it clock. We should trigger the clock flip flop. And let us see output. Q is the main output that stores the data of the flip flop. QB is the complementary output. Okay, complementary output. And let us see the flip flop behavior here. Always I should, as I told before, always is the keyword. um, so here the flip flop is sensitive to the positive edge of clock. It also includes a synchronous set controlled by a reset input. Synchronous reset. Yeah, so this is synchronous reset. If reset is high, that means 1, the output Q is immediately set to 0. You can see here. It's for synchronous reset and begin else, let us say else statement. It's begin is a built-in keyword. Hmm, let us see case, okay. So begin 2B what and all we can see. So here 2B00 means no change to Q, means the answer is same as that of Q before, okay. So 2B01 means reset, means 0 means reset, I told before, okay, in previous video. And 2B10 means set to set state, means not reset, set state, which is 1. And this is nothing but invalid state. I told before, no, invalid here, you can see invalid state, which indicates an indeterminate state. Complementary output. Let us see complementary output. So this is complementary output, and the output cube is always inverse of q and is assigned directly as assigned qb is equal to negation q. This is all about SR flip flop. So let us see JK flip flop. So same as that of I told difference no between SR flip flop. So see here you can see invalid, but here you can see toggle. Okay, that's what. And other and all same like you can see here also. Here you can see SR, but that and all input name. But here you can see JK. Okay, and all other are same. All other are same. Let us see once more. Here J means set input, and K means reset input. Clock means we have to trigger the clock. RST means the synchronous reset output. So Q means the main output of the flip flop. Here Q main output of the main output, that is. QB means the complementary output. QB means negation of Q. No, that's what. Let us see flip flop behavior. Synchronous reset. If RST is RST, yeah, RST is there. No? If RST is high, then Q is immediately set to 0. JK, let us see JK inputs. The flip flop updates Q based on the values of J and K as follows. Let us see the else statement. So begin is a built-in keyword. If 2B00 means there is no change. See, you can see there is no change. Input is also Q, output is also Q. So 2B01 means set state, which is 0. Sorry, 2B01 means reset state. Okay, reset state. 0 means reset state. 2B10 means set state because output is 1. So that's what. 2B11 means toggle. Means oh, just toggle means input is 1 means -1. So that's what. Sorry, 0. 1 means 0. Negation of that. Okay, that's what. Output will be QB. QB will be minus of Q. That's what. So this is all about JK flip flop. So let us see output also. So this and all. We have to right click on this to input. We have to right click on this and force clock. We should trigger. No, so that's what triggering. So this is the main output of JK flip flop. This is the main output of a SR flip-flop, and this is main output of a D flip-flop. So that's all about. So thank you.